Thanks, Dwayne. Kia ora koutou. Yes, if you're here for frogs, I apologise. This is the only frog you're going to get, so it's a bit of a random reference. But it refers to that kind of saying that if you put a frog into a boiling pot of water, the frog's going to jump out straight away. But if you put the frog into the cool water and then gradually bring it to the boil, the frog doesn't notice it so quickly. So are we leaving our ecosystems to boil in a changing climate? And I would argue that perhaps we are. So if we look at the information available on climate change impacts here on our bioheritage, there's not a lot of evidence to show that we're seeing impacts. So in a 2011 paper, Carolyn Lundquist and colleagues found, they used 67 different references, but only 7 of those were actual references to climate change impacts here in New Zealand. And similarly, a 2010 chapter in this report for the New Zealand Climate Change Centre by McGlone and colleagues, the biological heritage chapter referred to 10 different examples of climate change impacts, and half of these were seabirds. So there's not a lot of really clear examples. And in fact, a Royal Society report that came out just last year was showing the same thing, that we're not seeing a lot of really clear evidence here. And there's obviously two potential reasons for this. The first could be that climate change isn't really a problem here, but the second could be that we're not really looking for it, and that's the leaving our frogs to boil problem. So when I first arrived here in New Zealand in 2010 from Australia, obviously there's heaps of climate change research happening over the ditch. And I realised there wasn't a lot happening here. And two male senior colleagues, said to me quite early on, well, you know, it's a very maritime climate and it's very mild. So climate change is not going to be a problem. And in any case, the climate is so variable, it's not really going to show up very easily. Those two colleagues have now changed their ideas. I won't name them, but they're now saying that, yes, they do agree that climate change is something that we need to look into. And Jan Wright, in her report on environment Aotearoa in 2015, said that climate change and the rapid growth of dairying were the two twin threats to New Zealand's environment. And Professor Leslie Hughes, who was one of the lead authors on the 4th and 5th assessment reports for the IPCC, said that there's a poor research record in the climate change space here in New Zealand. So Australians are really lobbying for more research to happen in this space. And of course, if we look at our greenhouse gas emissions, they're very high per capita, and we don't have a good record within the OECD for our environmental performance. So this report came out just in March, showing that New Zealand's environmental performance is pretty bad, particularly when it comes to greenhouse gas emissions. So what does climate change look like for New Zealand? This nice infographic shows across the country what the different effects might be in terms of the changing climate. And so if you look into it closely, or even if you just look at it quickly, you can see that there's quite a lot of detail going on there. And what we see is that across New Zealand, there are not consistent patterns in climate change. And this makes it quite complicated, because some parts of the country will become drier and others will become more wet. There are differences in terms of storm patterns and all sorts of different processes going on. So when it comes to understanding how climate might affect our biological heritage, it is definitely quite complicated. But we can identify a number of clear threats to our biological heritage. And we can sort of list these. And the first is rising sea levels. So obviously, as an island nation, we have a lot of coast, and rising sea levels will affect us, not just the people living on the coast, but also organisms in those areas. We can also talk about extreme events, and this is something that we're seeing across the world. Extreme events are those events that have the potential to have the most impact on natural and managed ecosystems. So these are things like droughts, floods, storms, heat waves, and fires. Now, the predictability, the variability, and the magnitude of these events are all changing. And we don't really have, a long history of, say, for instance, things like droughts. Our droughts here last for 3 months, but we're seeing across the globe the patterns are that when our ecosystems are not used to having droughts at all, even a short drought can have a serious impact. We also have problems, obviously, with freshwater availability, and that's linked back to drought and other processes, and then also, finally, ocean acidification. I'm not talking much about the marine realm here, but really focusing on terrestrial and aquatic ecosystems. So if we think about what would be the best way to really understand what's going on in terms of how organisms respond to a changing climate, there was a nice paper in Science in 2011 that talked about 4 different processes by which organisms can respond to environmental change. So we can start off with toleration, where the organism just deals with it. They stay where they are, but they may be in a suboptimal sort of state. So they might start to get stressed. The next one there is habitat shift, and this is where they move small amounts of distance. After that comes migration, where there's large movements, and then finally extinction in the worst case scenarios. Now, different species can respond in sort of multiple modes across different times, and this might be particularly true if a population is fragmented. But these sorts of things can be detected quite clearly, and we see lots of reports across the world of different populations responding to climate change in these different ways. But the way that we can measure these, there's lots of different approaches to understanding and typifying them. And the same paper looked at 2 types of ways of understanding the processes. The first was empirical and observational, and the second was mechanistic. So empirical and observation things include things like direct observations, paleoecological records, and finally climate envelope models. And then for the mechanistic methods, these are obviously understanding the underlying processes. We have ecological models, experimental manipulations, and finally population models. So these types of approaches are the ways that we understand and detect responses to a changing climate. So in an ideal world, we would have data sets available to us that we could then explore to see, what's happening here in New Zealand. Unfortunately, we don't have that. But we do have some clear examples of climate change threat. And so the first is tuatara, and we know that when temperatures increase, you're more likely to get male eggs. So a change in climate will affect the sex ratio in this rare reptile. We can also see quite clearly that we have shrinking alpine ecosystems as tree lines advance further up mountains. That's shrinking the available landscape for these alpine ecosystems. And in a similar way, we have rising sea levels as squeezing coastal habitats. So there's nowhere for the coastal habitats to move as the sea level rises. So sea levels have risen about 19 centimetres across the globe since 1901. So clear amount of water coming in there. And then the final example I've got here is the increasing frequency of megamasts, and this obviously increases the impact of predators on vulnerable ecosystems. Now, the first 3 that I've shown there are kind of quite direct impacts of climate change, but the last one here is an indirect impact. So it's not the climate change directly that's impacting on the ecosystem. And I think these are really key to the New Zealand situation. There's also lots of other less clear examples. So, for instance, we have fragmentation of rare populations, possible reshuffling of ecosystems, declines in productivity. So it's not just about whether a species exists or not, but it's also to do with how well it's performing and how the ecosystem services are coming about. We really know very little at all about responses of our native vegetation to rising concentrations of carbon dioxide. Shifts in ecological processes like pollination, interactions between climate change and invasive species, and that's the last one I have there, but all of these we can kind of get a feel for. Yes, they're probably likely to be problems, but finding that clear evidence is more of a challenge. Now, just to highlight the fact that obviously we're not the first ones to think about this, but in 2013 there was a Department of Conservation report that was talking about proposing a framework for the conservation of terrestrial native biodiversity in New Zealand, and so these 5 strategies were developed. And obviously, if we're going to address these strategies, we need to start with the first one of those, which is improving our knowledge and understanding of climate change impacts. So with that in mind, a group of us met late last year in a workshop funded by the Biological Heritage National Science Challenge to think about what are the research needs for a changing climate. So there were 18 of us from across the country and a really diverse range of expertise and also career stages. Mostly ecologists, and we had one climatologist so that we weren't going completely off track. And we spent 2 days talking about what we should do in this space. So for the rest of the talk, I'll just tell you a bit about what we did. And initially, we started off by thinking about, well, what are those research needs? And we came up with 45 pressing research topics. And I doubt that this is a comprehensive or complete list of things that should be done. It's just what the people in the room came up with. And there were all sorts of different things that we thought of in that process. So things like physiological limits of organisms, that's native organisms as well as introduced organisms, impacts of climate change on kaitiakitanga, all sorts of different interactions and how they might change, vulnerabilities of species and ecosystems, how can we identify which ones are going to be having problems. It was really a grab bag of climate change potential impacts and required research needs. But one thing that we thought about quite quickly was that there's a real lack of long-term data sets. And we thought about, well, where are the long-term data and where are the databases, who's responsible for those, and can we get it all together? And that in itself would be sort of the starting point, we decided, for the types of work that we would like to do if we had unlimited money and unlimited time to do these things. But in going through that process, we quickly realised that we needed to think of a way of tying this together, and we needed to take a step back and get out of the nitty-gritty and think a bit more strategically about what or how we could go about thinking about this in a more directed way. So we thought then about what is it that's unique about the biota and the environment of Aotearoa, and obviously there's a few things that have come up that are consistent with the other talks in this session. So we have a large proportion of endemic species, and also a large proportion of fragmented populations, which makes them really vulnerable to changes. So having so many endemic species means that whatever's being done overseas might not necessarily apply to the organisms that we have here in New Zealand. We can also definitely say that our greatest conservation threat is invasive species, and that's irrespective of what's happening with the changing climate. And we also live in, as I said, a very highly variable climate and a highly coastal climate. And so all of these factors sort of mean that in a global context, the New Zealand climate change situation is quite unique. And then finally, we thought that, like I touched on before, the interactive effects are likely to be the main influence that climate has. And so these threatening processes that we already have are likely to be exacerbated by the climate. Now, some of these are well known, but others are less known. And the ones that we don't know about might be ones that we don't know that we don't know about. And so we don't know that we need to look at them. And so it becomes quite this complicated discussion about the known knowns, the unknown knowns, and the known unknowns, and how we can fill in all of those gaps. So we decided to go with an approach looking at a number of different species and populations, habitats and ecosystems, and ecological processes that we predicted would be influenced by climate change. And so this is not a complete list, but it's simply some case studies that we could use as representations of the different processes that might, or the way that climate change might play out in affecting these different processes, habitats, and species. So this really represents some of our areas of expertise that were in the room at the time, but it also represents those cases that might be well known as being not well known or whatever it was. So we decided to then think about all of these different things on this understanding versus data availability matrix. And so we placed all of these different items, I guess we could say, within this space. And this is really just a relative representation of those different things. And so if the item occurs sort of at the top half of the graph, then we sort of assume that we had quite good data availability. So there's a reasonable amount of information available. But if it occurs towards the right of the graph, then we have a good understanding. And so we sort of have this matrix where we can have a really promising information and understanding in this square, obviously, and then the opposite of that is we don't really have a lot of data available and we don't really understand what the processes are. So let's look at how we put those onto that. So we know quite well that mast seeding, tuatara and TT, clearly we know we have quite a lot of data and we have a reasonably good understanding. Of course, there's always more that we could know and there's always more questions to be answered, but in the relative space, those things fit there. Mudfish, maybe a little bit less data availability, maybe a little bit less understanding. Archie's frog, oh, I did lie, there's another frog here, so for the frog enthusiasts. And braided rivers fit in that space. And then these ones here that we have a little bit less understanding of, but quite a lot of data. So sometimes we do have a lot of data, but not a good understanding. So elevation of tree lines, birds and land cover change, and then moving down into this space here where we have less data availability, but maybe still a decent understanding. Fire and weeds, long-lived systems, and then these ones here are the ones that we don't know a lot about and don't have a lot of understanding of. So a lot of variation in what we think we do and don't know, and I should explain too that this is just our understanding of the current situation. We now want to think further about, well, what can we say about each of these things in terms of what climate change processes will affect them and how will they work. So that's the next step of the process, and we're also going into each of these items and sort of expanding them out and getting into more of the nitty-gritty of how they'll work. So a bit more work going here in terms of understanding what those underlying processes may be. So in conclusion, for the talk for today, so I mentioned that it's all about exacerbation in the climate change space here in New Zealand. So things like freshwater quality and quantity, arrival and survival of new pathogens and introduced species, of course, tragically the perfect example of myrtle rust arriving so recently. Further fragmentation and habitat degradation, all of these things are going to be made worse by climate change. And of course, things like extreme events, the extensive fires where vegetation is not adapted to fire, so Port Hill is a classic example of that, likely to be revegetated by weed species rather than native species unless we work really intensively in that area. And things like extensive drought are causing huge impacts across the globe. It's probably only a matter of time before we see drought mortality happening here in New Zealand. And so these processes cause big shifts in ecosystems. We need to find ecological and cultural solutions to these issues. And this is a watch this space because we're working on a paper to explore all of these things further. And finally, I should tell you my crazy and ambitious idea. Of course, taking action on greenhouse gas emissions has got to be the first one. But also, if we can include climate change research in all of the research that we're doing here. So very few of the speakers have mentioned climate change research, and I guess it's always just another add-on, another extra thing that has to be done. But we can really clearly see that the climate change that's happening here in New Zealand now, if we don't get a good handle on it, and we don't all understand how it affects the different things that we're working on, it's likely to undo a lot of the great work that's being done. So let's think about climate change in all of the research that we're doing in conservation. Thank you.